بسم الله الرحمن الرحيم رب زدني علما.
So after discussing the basic differences between the different types of protocols, again there is something called EGP, IGP also. Again, this is something I'll cover a little bit later. Interior gateway and exterior gateway protocol categories. And the main thing here, we need to understand RAP protocol. Now, in terms of RAP, I already said RAP is not really used routing information protocol because there are a lot of drawbacks. It's obsolete, so no more used anywhere. Because for many reasons, we'll see those reasons here. But still, and it is no more part of any of the syllabus also. So most of the new devices they don't even support RIP. But still, I consider to discuss this protocol because if you want to understand the dynamic routing and how it works, of course, we covered some theoretical stuff. But if you want to understand how the dynamic routing works, we need a simple protocol to understand. That is what RIP is. So RIP is the simplest when compared to the OSPF. So if I directly jump into the OSPF, it will be a little bit complex. So what I'll do is I'll try to cover up one session on RIP to understand the behavior of dynamic protocols. So every protocol works differently at the end, but the backend core job remains the same. Okay. So let's try to understand what is RIP. RIP, Routing Information Protocol, that's what it says. There are two versions, version 1, version 2. We'll talk about the differences later. It is a open standard protocol. Now, open standard means, like I said, whenever we say standard means you can run this on any Cisco or any non-Cisco devices. So if you're running any D-Link router or Juniper router, so basically you can run between or any other devices. And also it is a classful protocol. Classful means, if you remember, we discussed, it will not carry the subnet mask information. So it will basically support the FLSM designs. And of course, there is an RIP version 2, which is going to be classless. Okay. So the version 2 has been introduced to support subnet. That is separate. We'll see. The updates are sent via broadcast. If you remember, I said the router is going to send out the update to the neighbor, and the updates will be sent simply out of all the interfaces. So the broadcast. So every interface enabled with RIP will be sending an update to the neighbors about all the routing information it has simply via broadcast messages. So there is no dedicated address reserved for that. But in the version 2, they have added that. Now, the next thing, what is the next thing? There is something called metric. Now, metric is hop counts. Now, here we use a term called metric to consider what exactly it will see to calculate the best route. Metric means what parameters it is going to check to find the best route. So here the best route calculation is done based on the hop counts, which means, let's say from the router A, if I want to go to 50.network, if you go from this side, there are two hops. Hops means routers. So here, when we say hops is equal to nothing but routers, nothing but next hop means next router. So if you count the number of hops from A to E, there are two hops, right? And if you go from this side, how many hops? Three hops. You have to go to first hop, second hop, third hop, right? So whichever the route is having the least number of hops, that will be considered as a best route, which means it will not see the bandwidth. It will not see the bandwidth. It will not see any other factors. It will only see the actual number of hops. Okay. Like in this case, from A to E, if you go from here, there are two hops. And if it goes from here, there are three hops, 1, 2, 3. So the best route will be decided based on the least number of hops. Okay. So what if there are more than, what if there are equal number of hops? Like take an example, there are three possible routes or four routes. One route is having three hops, another route is having three hops, and another route is having four hops, and another route is having, let's say, five hops. So in case if it come across scenario where in this scenario, three is the best, three hops. And if there are more than one route which is having the same number of hops, it will do something called load balancing. So that's what it is. Load balancing can be done up to 4 equal paths. Here it is 2, but up to 4 equal paths, it will do load balancing automatically. Now, load balancing we call as equal cost multipath, nothing but load balancing. It will send the packets from both the sides. So both the routes will be installed in the routing table as a best route, and it will start using both the routes. If there is more than one best route, it will write down them in the routing table and it will include that. Okay. Now, another thing, the maximum number of hop counts is 15. Now, this is the limitation. So, which means if you're running RIP, it will support only up to hops of 15, means 15 routers, maximum distance, and the 16th hop is unreachable. So, including my router, if I am connecting only, let's say 16, 15 hops, that is good enough. But if your network size is 100 routers, and to reach from this router to the 100th router, there are more than 30 hops, let's say 30 routers. This is not going to work. So the maximum hop count only supports up to 15. So if I count my router, then mostly like 16 routers, 15 to 16 routers is something we can limit. That too, assuming you're connecting serial wise like this. Maybe if you're connecting something like this, you can have more number of hops. But generally, the hop count will not work beyond 15. That's the maximum limit. 16th hop is unreachable. So that's the reason we say this particular protocol is applicable for small organizations. Because if you're connecting like 15, 16 hops or 15, 16 routers, 15, 16 locations, it means it's a small organization. Okay. So whenever you are talking about any branch office, let's say if you take any government office, so you have a government office, let's say in the capital city, Delhi, then you have every state you have a different branch offices, and then in each and every state you have more than hundreds of offices. So if you take any medium to big size organizations, you will have at least 100 plus sites. Okay, so that's what we will be dealing with, especially when you go to advanced routing in the CCNP, you'll see those things. So RIP, the main reason RIP is not applicable because of this reason. The maximum hop counts is 15 and applicable for small organizations. So again, there is something called administrative distance, which we have seen. Administrative distance basically tells the best route, whichever the default value is 120 from Cisco. Basically, administrative distance is like, let's say if I'm receiving some information from OSPF and also from RIP protocol, the router has to listen to any one, and it will listen based on the administrative distance. The default values are there. So the administrative distance is something separately covered in a separate video to understand that. So it will listen to OSPF, which is more trusted compared to RIP. So static will have administrative distance value of 1, and RIP having the administrative distance value of 120, OSPF 110, EHRP 90, like that. These are the default values given by Cisco. And again, every vendor have a slightly different values. So whichever is least, that is more trusted. Okay, so like that, the trust number, we can say it's a number given to define the trustworthiness. So it is 120 value given, and this is something we'll see in the routing table also. I'll show you this when you use show IP route command. When we verify the lab, we'll be verifying this at the time of verifications. And one more thing we discussed in the case of the protocol, the distance vector protocols, they use the algorithm, right? What is that? Bellman-Fuld algorithm. It will exchange the update for every 30 seconds. So the updates are sent via broadcast, and it will be broadcasting the update for every 30 seconds to the neighbor. So which means for every 30 seconds, there is a continuous periodic updates between the two neighbors for every 30 seconds. That is a default. Okay. And again, the convergence we'll see later. As of now, we'll see the timers. And if the neighbor goes down, it will stop sending the updates, and that's where it will start calculating the other rule. So that we'll see in the timers. Okay. So the first thing we need to understand about the RIP is a standard protocol, which is again the classful. The version 1 is classful, version 2 is a classless, and the updates are sent via broadcast. Again, the version 2 will send via multicast. Multicast it uses. Again, the comparison I'll do it in a separate. And the metric is hop counts, which means it will count the number of hops to reach, and whichever the route is having the least hops. Hops means the routers. That will be the best route. And what if there are equal number of hops, like 2, 2, 3, 5, then it will do load balancing. Up to 4 it will support. And the maximum hops it supports is 15, maximum hop count. The 16th hop is unreachable. And that's the reason it is applicable for small organizations. And again, there is a periodic update for every 30 seconds. And the administrative distance value is 20 for RIP, which is the trustworthiness of the information.